Okay, so this is the notes for those that are missing the notes in class. So this is the quick and lame version instead of the interactive one you would have gotten in class. All right, this is on classifying chemical reactions, so chemical reactions, but the classification. All right, I'm going to go quick on the video. If you need to pause it to write words down, please do so. Okay, most common chemical reactions classified into 5 very general types. There are some more specific ways to classify them. If you take the college chemistry class or go on into chemistry, you'll find that there are more specific. We can break these down, but you can always go back and classify them into these 5 general types, okay? The first type is combustion. These are the ones, as you've been balancing, that have probably caused some problems on some of these, okay? It's the rapid combination with organic, sometimes inorganic compounds. We call it combustion, but it's really technically not. Almost always releases energy, okay? The general form is going to be a hydrocarbon plus oxygen, gives us carbon dioxide and water, okay? Most often it's just going to be C and H. Sometimes there can be some oxygen already here in the case of like sugars and alcohols when they burn, but the products, it'll always be a C and an H and maybe oxygen, and then plus O2 gives us CO2 and H2O. This one's already balanced for you, okay? That's how you can always tell, you know, this part will always be the same. So when you look at a chemical reaction, if it starts with C something, H something, and something else, and then plus O2 gives me CO2 and H2O, it is a combustion reaction. Decomposition is just what it sounds, okay? Decomposition is when a substance will break down into simpler substances. Generally, after you apply energy, some are unstable, so they'll break down on their own. The form of energy could be heat, light, electricity, etc. Okay? So it's going to look something like this. These are general variables used to represent elements. AX gives us A plus X. It could be more complex, break down into more stuff, especially if there's a polyatomic ion on the left side. The key thing is there's just one reactant and there's multiple products, okay? So again, it could be something like that, could be a lot of different things, all right? So that is an example of decomposition, all right? Single replacement is type of reaction which one element replaces another within a compound, okay? I sometimes call these the swoops. Somebody swoops in to steal somebody's girlfriend or boyfriend, all right? A plus BX, the A comes in, kicks out the B, all right, and you end with AX plus B, all right? Now, key thing, all right, I don't have this typed in here. If it's the positive thing, the metal, all right, if the positive ion is what switches, we call that a cationic single replacement. And some books, some texts, some professors will refer to it as single displacement, same thing. All right, if it's the negative ion, then we call it an anionic single replacement, okay? That's important to be able to make that distinction. So if it's the second thing, all right, if fluorine replaces chlorine, that would be a cationic, or excuse me, if fluorine replaces chlorine, it'd be anionic. If strontium replaced potassium, that'd be cationic, okay? So that's important to remember, all right? Dun, dun, dun. Sorry, I'm having trouble switching my pages. Okay, all right, synthesis. Oops, let's get rid of this. We don't have cationic and anionic synthesis. All right, synthesis is also sometimes referred to as combinations, all right? This is when 2 or more substances are combined into a single product, all right? It's the opposite of a decomposition. This is not necessarily how we make new compounds in the chemistry world. This does happen in nature, but in chemistry, a lot of times we use the single replacement or double replacement. We find something similar to what we want and we adapt it, put something else in there, all right? The key thing here is you have a single product. So 2, and these could be single elements, It could be a compound and element, but the key is a single product. That's how we would know it's a synthesis reaction. All right? And the double replacement, all right? And these are ones that can definitely be reclassified into different groups, like acid-base reactions, precipitate reactions, things like that. All right, but that's on down the road. All right, in this type, the positive and negative portions of both compounds, they switch places. It's kind of like a square dance, okay? All right, so these often look the most complicated. All right, you have AX and BY, and then it gives you AY and BX. But if you notice, because we always write the positive thing first, a positive always goes with a negative. So you wouldn't end up with AB and XY, all right? So it's gotta be, the positive goes with this negative, the positive goes with this negative, okay? All right, that's the quick version of the notes. Again, we acted out in class, so you're missing out on good times. But this way, if you're gone, you at least have it. On Monday, you will be, you'll have a worksheet. One side you're just gonna classify. The other side, you have to write out the reactions from the word equation and then balance them and classify them, okay? All right, good luck to you. We'll see you in class next week.